Hey, good afternoon, everyone. Can you hear me well there? Okay. Yes. Okay, so welcome to the session about AI innovations in DHIS2, in top of DHIS2. You know, and I think that when we were thinking about the title, like it was 2 months ago, I was thinking, okay, maybe let's have this title about how we can empower DHIS2, make it more powerful using AI. But I'm feeling like over the last two days, we have been talking about this already on Tuesday, in several sessions on Tuesdays, on several sessions on Wednesday. So today, when I wake up, I say, okay, yeah, I don't know what we are going to talk about now. Should we change the title of the session, or maybe it's a bit too late? So we talk about DHIS2 and pattern theory, that is going to be like a trend topic probably in the future. But no, I think it is very nice that we are seeing already, like many organizations, many countries, innovating with AI and DHIS2. That is fantastic, fantastic news, right? So I think that today we are going to see 3 examples that we are going to explore. We are going to discuss like different kind of AI techniques. We are going to talk about predictive analytics. We are going to talk about classic machine learning. We are going to talk about generative AI as well at the end, right? And I think it's going to be, if we have the time, I would like to also generate some kind of discussion, because I think that it's going to be, we see this as an opportunity, AI and DHIS2. But maybe also there are some risks as well, right? Because I mean, if DHIS2 has been the system, very successful system over the last 30 years, it's because of the principles that we have, right? So we believe in the community that we have, our transparency. We believe in our the security of the data, and also we believe in the local ownership. So now that we are going to use, we are exploring, starting to explore like new techniques, AI techniques now without the explosion of generative AI. Are we at risk? Are some of these values at risk or not, right? So I think hopefully we are going to have at the end a very nice discussion. But let's start with our first presenter, Jerry. So yeah, please, whatever you want. Or machine learning and
Yes, thank you. So I have presented before on climate health, and I will mention that here, but in my daily life, I'm a machine learning researcher. So I thought I should also use this opportunity to try to kind of shed a bit of light on what is machine learning and what is AI, just to give a bit of a general background on it. So the first thing, and I think like as a machine learning teacher and a machine learning researcher, this field has a bit exploded. So I think it's a bit important sometimes to think about what is really this generative AI LLMs and what is machine learning. And we often use it as synonyms, because if I'm showing a slide about climate health modeling, I just know I don't have time to go into it. But I think for us as a community, it's also good to try to think a bit about the distinctions. So what is the difference between machine learning and what is and generative AI? And I usually start with this to say that everything was easier before, because describing AI was very easy back in the days. It was the ambition of building a machine that could convince a human that it was also a human through conversation. So this is, for anybody that has studied machine learning, this is a classic test that is called the Turing test. It was conceived around 1950, so it's more than 70 years old. And the idea is, as in this figure here, right? You have a machine. This guy, he's just like sending notes. We didn't have printers at this time, right? They were sending kind of notes back and forth through a small slit, and with one there was a person and one there a machine, and the question is, would he know what is the machine and what is the computer? If you cannot distinguish, then we have artificial intelligence. There was a lot of techniques introduced already back in that time, and what was common, that they were very cruel already then. They clearly didn't work, and they weren't useful for almost anything. And this is maybe one of the first systems that are known. It's called ELIZA. It was kind of a psychologist. So you could type something like, men are all alike. And then the system responds like, in what way? And he said, they're always bugging me about something or other. Can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here? He says I'm depressed much of the time. I'm sorry to hear that you're depressed. So this was, and it's actually extremely simple. This is just a small computer program made in 1966. Some people think like now we will have psychologists. So in 5 years, in 1970 maybe, we will not need to go to psychologists anymore because we will have this computer program. Of course, it didn't happen, right? Now we are a bit in a different phase. This is just repeating a bit of words, but it kind of gave that impression. Today, it's very difficult to tell what AI can do and not. And I think that is like sometimes that's what's scaring us also, right? And my son had bought a book. He's a Norwegian researcher telling like what can AI do and what can AI not do. And he asked me like, but Dad, he says here that AI can never do this, but isn't that what's happening when I'm using like ChatGPT? And I said, yeah. It wasn't possible half a year ago when this researcher made this book, but it turned out to be possible just after it went to print. And I think that is like how we are all feeling now, right? Should we do programming ourselves? What about documentation? What about translation and all this? So this is kind of the classic definitions of AI. I mentioned the Turing test, convince it's human. And then somebody says like it's automation of activities that we associate with human thinking, like decision-making, problem-solving, learning. I think it's quite close to what we often want to do. Maybe the study of computer programs behave intelligently. And some say like a bit later, around 1990, the art of creating machines that perform functions that require intelligence when performed by people. So now it's kind of saying like maybe it's not whether it's intelligent or not, it's not so important, but it's kind of being able to perform functions that we before needed humans to do. And this is my favorite about what is AI. It's the study of how to make computers do things at which, at the moment, people are better. Right? So this is kind of how I feel now, right? They are kind of taking over more and more, but at least AI systems try to do that. And I think that this ChatGPT came along, right? And that is like what has driven the current strong interest for AI. And the important thing is this ask anything. That was not conceivable. I never thought that this would happen if you had asked me 5 years ago, that you can kind of ask anything and it just works. But it kind of works for quite many things, right? Just to mention that actually the revolution for us in the field kind of came in 2012. And that was something, the first time a computer could do something that was typically better for humans, which was to distinguish cats and dogs in a picture. And this kind of had a cascade of, as you might know, the real inner working of ChatGPT is what is called a perceptron that was launched in 1958 and really starting working well in 2020. Right? It took 60 years. So a main point I want to say today is to think of machine learning and generative AI as two distinct techniques, and I'll show a little bit of this. So machine learning is to learn complex patterns or relations in data for specific questions you have. And what I mean with machine learning is that like how is it able to learn it? That might feel a bit magic, but what it learns is very explicitly defined. So if you want to predict diseases 3 months ahead, then you are using machine learning. You have your question, how much malaria will you have 3 months from now? That is a machine learning question. If you say, will I have sufficient stocks of drugs in my region? Is that kind of disruption coming? If you're doing that, you're still in machine learning. You're defining a very specific question, and you're saying to the computer, use your magic to kind of find the answer to that question, to learn the patterns, to learn the relation. The other thing is these large language models, that is the most important type of generative AI, and they can just do almost any kind of thing, right? And you don't even know, you don't have to train it in the same way. You just come in there and you say, like our prime minister was here yesterday, and he said, like he had gone to ChatGPT and because he had met Donald Trump some weeks ago, and he said, I went to ChatGPT and said, give me 5 good suggestions for how I should act when I'm with Donald Trump. And he said he had to follow some of them. Right? So it's so kind of open-ended. But we have to think about this too, because I think like this is useful for almost anything. Like you can improve your productivity, but it can also fail. Machine learning, that's when you have a very specific thing and say, let's use a machine to find these patterns, these relations. So it's a bit closer to a calculator, very sophisticated calculator. So I will not go into generative AI because we will come back to that. But just to say, right, you can write professional text based on your kind of brain done. You can translate from French to English or any other language. You can sometimes find information or facts, but here I'm always a bit wary. You cannot really trust it today. You can summarize information, but again, be a bit wary, I think, because is it really extracting the right aspects for me? It can sometimes help me learn. I can say, can you teach me machine learning or something like that? Make a report that's suited for me. Can you tell me what's like, let me make a report, 10-page thing about public health and understanding public health challenges in my country, what I need to think about, right? You can use it to generate information that you again learn. And you can do the mathematics with it. It's better than humans now on a lot of mathematics tasks, physics tasks, computers programming tasks. One machine learning, and then it's against various types. The simplest is supervised machine learning, which is a way to learn how one thing relates to another, which can be very complex. And you tell them by example. So it's kind of learning by example. That's why it's supervised. So it's like having a trainee. And sometimes you need a lot of data. So this is kind of saying like, can you say that this is a hexagon, this is a rectangle, this is a triangle? You give it a lot of these examples. When you now just put in the shapes, the system will tell you this is a square, this is a triangle, because it has learned these reflections. I will just very briefly show this climate health example because we have seen it before. But this is kind of this famous slide that we've seen too many times. We're just saying that climate affects health in so many different ways. And these relations can be very complex because it has to do with vulnerability, exposure, and how the system operates. And then you go from the climate, which can be rain, temperature, vegetation, and it's a very complex relations down to, for instance, cholera, malaria, and a lot of other health impacts, like maternal health. Since these are so complex and the question is well understood, this is a task for machine learning, not for generative AI. You cannot go to generate, like you cannot ask ChatGPT, like predict malaria 3 months ahead for my country. Even if you provide it with data, it's not meant to do that. Then it will have to make its own machine learning system and help you make that. So machine learning is like where you put in, these were the climate data back in time, and this was the malaria. So basically you put in the data, you say, there is some kind of formula. I don't know exactly how that formula should be with complex relations. And I want to end up with like, these were the regions where there was a lot of malaria. This is an example of Vietnam. And essentially it's like this. You are curious about malaria cases in April because you are now in March. And then you say, how can I learn what the malaria in April will be, given what the malaria were in the month before that, as well as how much rain we had in the month before and what was the temperature. That is essentially the machine learning, which is a very well-defined question. So you do two things. You train, and when you train, you say, these are all examples of how the climate was in the past and the malaria was in the past. Based on that, learn the formula that translates from everything in the past over to malaria afterwards. So how was malaria and climate affecting what happened with malaria in the time? Then you use this formula. When you have learned it, you put in now, this is what I have of malaria up to now. This is what I have of the climate up to now. Now tell me what will happen ahead. Just to mention that in practice, of course, it's a bit more involved, but it's not too advanced what I'm showing here. But it's just like you have the train and you use it to predict and you evaluate, of course, how well it works. With machine learning and with AI, I guess you have to be into the loop as a human and to see, does it really work? Then you have to do the validation and you have to try it out in pilots. And we have gone into that yesterday in the climate health sessions. But it's just like, you have to have a rigorous process around it. But at the core is like telling the computer just to learn the patterns, but you as a human handle all the context. So this is more like a fancy calculator. So this is how it looks for climate health, just as an example, where there's a lot about like population at risk, this was dengue cases, climate, land cover, monthly effects, how the seasons are, and so on. And then when you look at such a formula in machine learning, since we have a formula, we know what the machine learning can learn and not. So this is a bit different from the generative AI. Like, what is ChatGPT really? If I'm asking, is like, is Rome a nice city to visit? I don't really know what lies behind it when it either recommends me to visit Rome or not. But in this, you can really see. So you can say, for instance, if I train this, I can say, maybe the rain in some regions of my country, urban countries, it has one effect on malaria, but on the rural areas, it might have a different effect on malaria. And then I can look into my formula, I can say, does this formula allow my machine learning to learn that it's distinct in the country? For this formula, I can see if I'm a machine learner, and if you collaborate with machine learner, they can tell you that, no, this one is actually assuming that the effective rate is exactly the same across your whole country, which can be for good or bad. And you can see a lot of things like how long back in time can it go? Can the rain have effect both like in the preceding weeks and further behind? And then to round up, I just want to say that remember that machine learning is also more than mathematics and statistics. And that makes sense for all of us here in our communities. There is a mathematical model here, but you need really the data to train it, right? So that you have a model which is a mathematical formula, but it is the data that informs that model, that builds up that formula. But even if you have that model, we don't do this by hand, and we don't do it on a single laptop. So we need a sophisticated software setup around it. And like a lot of the time when you do machine learning, maybe it's more work to get all this kind of computation infrastructure in place than it is to develop the mathematical model at the time. So like all the know-how we have in our HISP community about like how to set up complex IT systems and infrastructures, that is highly relevant. And finally, what is really hard is the organizational adoption and see how the organization needs to kind of adapt and relate to it and exploit the opportunities. So I think like statisticians and machine learners should be part of the picture, but they should play a minor role. So it's actually software engineers and action researchers or implementers. They have like a very big role in making all of this kind of work. So this, just to end, is the setup that we have in our system, where we have made I think it's been 90% software development and maybe 10% mathematical modeling and maybe 200% implementation. Right? But what we really want to do is to make a computational infrastructure and process that allows all of this development to happen within the country, keeping the data inside the country, having ownership, having capacity building and everything, and the critical assessment and the control inside the country. And that requires a sophisticated process and an advanced IT infrastructure. And just to round off, also I want to say that we have now done this through specific funding for climate-informed disease prediction. And we have then developed a lot of functionality for this already, as I mentioned. But when we actually look at it, you could rip out the climate thing actually, and you could still use it. So most of this is very generic, open-ended in its nature, which I think is quite typical with DHIS2, right? You made it for a case, but you could easily generalize it and use it beyond. So any prediction of a DHIS2 data element ahead in time, you can already do with this modeling app. You can have kind of any kind of health impact. It could even probably be potentially education and logistics and any kind of that. If you are curious how this will develop ahead in time, we have the kind of software infrastructure, to some degree also the mathematical models. that can be used for that. And of course, if you want to use it for anything serious, you have to think about the tailoring and evaluation and so on. And with that, I give the word.
Oh, thank you very much. I think that all we have learned very much. Thanks a lot. And our next presenter is Oswald Mossi from the University of Dar es Salaam. And he's going to talk about the event surveillance systems with AI and learning leaders. We're going to have, if we have the time, the questions at the end, okay?
Hello, everyone. Can you hear me? Yeah, thank you. My name is Oswald Mossi from the University of Dar es Salaam. Yes, I'm here in front of you presenting how we've been able to automate the trial process in DBS, in which this has inspired the use of AI. So just a little bit of introduction. The WHO, the standard guideline in which the Minister of Health has been intensifying these efforts and upgrading the event-based surveillance, which aimed to early detection and rapid response to health threats. So just by 2021, we were able to digital transformation with the EIDSR, and 2022, we were able to see the impact of EBS, of which the very first Marburg virus disease were detected using the EBS. Taking a moment to define what really is EBS. We all know EBS is the proactive strategy, which aimed at collecting or gathering all signals from various sources, either hotline, calls, social media, but more importantly, the community engagement. And for our case, it has five stages, of which involve the reporting of the alert, triaging of the alert to know if it's a true concern, or filtering, then verification, investigation, and lastly, the action. So how is EBS reported in Tanzania? We have four ways of reporting EBS. First one is the direct message, which is being sent through 199 with the keyword TESI, the Swahili word, which means alert, then the district of which the event occurred, then followed with the content of the message. This is the first one. The second one is dialing Dutch code, *152*05#, following the menu for reporting. The third one and the fourth one is the Android and the web, as you can see. So out of these stages, as I said before, the reporting, triaging, and verification, investigation, and action are all crucial, but we all know triaging is very central since it involving filtering these alerts, the relevant one from the noise one. So, and it involves, as you can see from the image from our case, to know whether an alert is a duplicate, it's an obvious mistake, which if it means it meets the predefined alert, or and it's important for early warning and response. So yeah, here comes the challenge. As you can see, for our case in Tanzania, EBS was trained in 5 regions. As you can see from the chart there, out of all tried, about more than 60% were untried reports. The discarded reports were about 16, and then only the credible were 23. So this has been a challenge since this manual tried to process has been insufficient, and this is due to the high volume of the reported alerts, but also the relying on the human intervention, which has been causing the delay in response for this outbreak detection. And due to that, together with the ministry and other stakeholders, we realized that if we are to manage this early response, we have to act fast and smarter. This is where the use of AI became a game changer. So, yeah, our objective in this implementation was to reduce the response time upon identifying the health risks, but also increasing the capacity to triage large volume of reports from the community. So here are our methodologies that we took. Yes, first was leveraging the use of DHIS2 platform. You know, EBS as part of ANSR implementing the DHIS2 platform. But also we use the keyword filtering together with the ministry, trying to gather as much as put the keywords that relate to health threats, but also vector similarities. We try to implement some vector similarities, and later on the potential use of large language models, which we are looking forward to that. So this is the sample screenshot of the keyword filtering that which is one of the approaches that we took. As you can see here, in EBS already we have the predefined alerts. They are both in Swahili and English, as you can see here, and then those are the keywords that we try to gather. So whenever a person or from the community puts an alert and it has any of the keywords here, then we filter them and then assign them to these alerts so that we can process perform triaging. So I hope you can all see this is the whole diagram or the whole approach of what we are to take. As you can see, the red one involves the rule-based approach, which we have implemented currently. The blue one, there's a potential usage of AI machine learning. And the green one, as we had a previous session, we could not avoid the human part. So there's a combination of both rule-based approach and the human intervention. So as you can see, I'll try to explain a little bit. So when an alert is being reported, we have to know, like, if it has been made within 48 hours, if it is from the same source, from the same place, it is of the same type. And if an alert meets all these criteria, then that means for our case, it has a possibility of being a possible duplicate. And this is where there's a human intervention come in. Then the healthcare worker will have to pass one alert out of many which were detected as duplicate and then discard the other one and then continue the process. But if an alert does not meet any of those, that means it's not a duplicate. And if it's not a duplicate, then we have to ask if it's one of the predefined alerts. If it is no, if it is yes, then we auto-triage the alert. If it is yes, we have to define using the keywords that I showed in the previous slides, the keywords that we've gathered and we filtered. And then once we found that there's a keyword that relates to what we are having, then it means it is being assigned to predefined alert, and then it comes to the same process to know if it's a duplicate. And if it is not, as you can see, there is where there's a potential usage of machine learning based AI techniques based on the key that I showed you there. So by finishing, the usage of AI will also help us identify the new keywords on which we will be able to update the keyword that we are having. So moving forward, as you can see from the screen, this is the way we implemented. Right away, a healthcare worker will be able to see the duplicate alerts, and then we'll be able to discard the one that are not related, or discard the other alerts that are not related, and only auto-triage one out of them. And also, the alerts that met the predefined alert will be auto-triaged. As you can see, this is the list of alerts that were auto-triaged, some of them which are ready for verification and investigation. So yeah, here are our results. We're able to estimate at least out of the trial, the alert that were reported, the manual triage, based on the calculation that we tried to make, average it took 36 hours to perform triaging. But right now, based on the rule-based that we have implemented, we are able to automate at least almost instantly. And then we are able to see that out of the reported alerts in the visa process, about 85% of alerts were processed successfully. So this were a big milestone, and even the ministry were very happy to see we were able to reach this milestone, of which we are now looking forward to the usage of AI. So here is the conclusion and the next step. Both AI-driven is very significantly reducing processing time, but also we also saw that the rule-based approach is very good, but it can be enhanced using machine learning algorithms. But also we have next steps. The first one will be we are trying to standardize the ABS metadata package to share with the community, but also enhancing the AI capability with large language models, expanding the deployment within the DHIS2 infrastructure, but also we are also continuing to collect feedback for system refinement. So by finishing, we'd like to acknowledge some of the partners, MDH, CBC, and DHIS2 during the accomplishment of this project. Asanteni sana, welcome Tanzania.
Okay, yeah, very interesting. Thank you as well. So our last example, we are going to talk about the generative AI now. Okay. But before that, as we have learned with here, if I don't know how to move this. Okay, so what we have learned is like a generative AI is the branch of the AI that basically generates content. The content can be text, can be images, can be audio as well. And I mean, over the last 3 years, we have heard a lot about ChatGPT, DeepSeek, and many other LLMs too, right? So let me ask you a question. Who is like using ChatGPT in daily basis for their work? One question. Who has been using ChatGPT or DeepSeek just to write abstracts to this conference? Only well, the reality is like, I would say, to have some creativity, to help us to give me some bullet points. And I think this can be really useful as well for the implementation team at Uvalio, right? So there are some challenges that over the last years, 10, 20 years, well, there are still challenges, but maybe this new technology can help us to speed up the process, right? So some ideas that we are like considering in the implementation teams, like maybe we are talking a lot about interoperability, right? Between interoperability between different DHIS2 instances, but also between different vocabularies, DHIS2 metadata, maybe also FHIR, OpenMRS, whatever. So maybe this kind of technology, this kind of approach can help us in order to do the data mapping a little bit. The can show you some data mapping, maybe based on the data element names, based on the description of the data elements, and so forth, right? So we are kind of experimenting a little bit with this. Like other potential use cases, like semantic conflict detections. So I mean, over the last 10, 15 years, we have seen many DHIS2 instances that has like a 50,000 data elements, 60,000 data elements. This exists, right? And probably this is like meaning that probably there's going to be a lot of duplications. Probably at some point we are going to lose track about what is the meaning of every data element there. And I think that this kind of approaches, using the generative AI approaches, it can help us in order to detect those semantic conflicts. Naming conventions, I think it's very important that we have kind of an structured way in order to call our metadata, attributes, data elements, programs, datasets, and so forth, right? And maybe we just can write a rule and basically tell ChatGPT or tell DeepSeek, can you give me like a list of data element names based on this and that, and they give us the payload already that we can import in the system, right? So we're already using this in implementation team, like when we, and it's helping us quite a lot to do our work. And also we have seen a very cool example, like over the last in that competition about the natural language queries for exploration. Sometimes instead of like, okay, I'm going to create a very complex program indicator and an indicator that combines the program indicator with some complex stuff, maybe we can get into a point that we can run our queries using natural language. Okay, maybe this can also give us some results as well. So as an example, so this is like a proof of concept that has been developed by Olaf. And basically, this is reading all the metadata we have in the system in a server. Okay, and basically, you select one data element, and basically, AI, the ChatGPT is, well, I can't remember the elements that he was using, but basically it's reading the name, the short name, the full name, the description, and basically it's like, okay, I think it's better if you just, the description is so full, maybe you can be clear there, maybe the short name, the full name is not clear enough for the user. So I think that we think that this can help quite a lot, right? But also, what about our principles? Because I think that all this technology is very powerful, but also what about accuracy? Okay, I think it's very important. If we are going to start to build application on top of it, we should be really very careful about accuracy. But about security, where the data is going to, okay? I think that is important. Where the data is going to, where the data is being stored, if I understand to this technology. Local ownership is one of the most important principles that we have had HIS, right? So whatever we do, we should be sure that the solution should be hosted in a local organization or in a country. That is really, really important. I mean, there might be organizations that for them is fine to go to the cloud. That is also perfectly fine. But I think that whatever we need to do, we need to promote the local owners. Okay, and also all the discussion about open source versus non-open source models, right? So we, over the last 20, 30 years, we have been always promoting the use of open source. So, and one of the most important use cases that we have seen over the last few years, I think, is about data entry, right? So there have been several initiatives, like, like trying to, is it possible when I have like a registry book that I can take a picture and basically I can read what is in the picture and send the data points, the values to the DHIS2 or not? And I think that over the last few years, we have seen some examples in the field, okay? But what can we do if we use the generative AI in order to just get that information? Is it possible? Is something that is promising or not? What is the level now, the maturity of the technology to do that, right? So SolidLines has wrote an abstract regarding like can Gen AI like improve like the data entry based on audios and images. And I think this is quite important because basically, I mean, there are people, health workers that are using the 30% of their time in order just to digitalize their data, in order to capture their data. Moreover, there are like people that their job, the 100% of their job is like getting this kind of very big registry books and digitalize them 8 hours a day, right? So yeah, I think that Carlos is going to introduce like some like a protocol that we have created in order to measure the accuracy of these models have with data entry. So,
very much, Jose. So, as Jose mentioned, we would like to assess if it is possible to use Gen AI in order to speed up the process of data entry into DHIS2, transforming audio and images into digitalized forms. So, what are we doing in this technology approach? Okay. So we need to first assess if the technology is already measured for the purpose that we want to be using. We want to measure the accuracy in terms of how good the Gen AI models are performing, how good the data is coming inside into DHIS2, and the difference between human data entry and Gen AI data entry. We like to test different kind of models, taking into account the open source models and non-open source models, just in case you want to use it locally, if you want to start in your own units. so data is not going somewhere. We're also trying to test different languages. So we tested in English, Spanish, French, Swahili, Norwegian. And we'll try to test others. And also try different prompts. What is a prompt? Is the instructions that you are giving to the generative AI in order to obtain a result. And at the end, take into account the cost analysis of using these kind of solutions that you need to take into account. So more than a final solution, we'd like to share with you an approach. And the approach that we are going to show later in the demo is that we have a web app that is going to grab, or you can upload images and audios to there, and it is processed by AI, generative AI, in order to enter the data later into the DHIS2. At the very beginning, there is a request of the metadata. So what are the forms that I can fill? And you obtain all the metadata, the data elements, or so on. So you know what you need to fill. So let's go to the demo. Okay. Just in case, later on, with the poster session, you will be able to test it yourself, okay? So we'll give you access to the application of the canonical approach, so you can test it yourself. So let's start with the first use case is enter a registry from a registry form, uploading an image, okay? So just to show that here, this is the form that we can select. In that case, it's child registration. I'm going to show, okay, it's a photo. And instead of, you can take the photo from the phone, but I'm going to upload the photo. And I'm going to choose the LLM. For this case, I'm going to use GPT for both. Okay, I'm going to drop here, that's one. And we see now it's processing. Maybe I can show you what I have just uploaded. So this is a photo of raised the book, synthetic. It's not a real use case. It's based on the information of the real use case that we see later, but it's synthetic. So we work on hand. So you will see that we have the different columns, and sometimes there could be an issue with a number that is over the line, and we're going to see how well the LLM is performing. Okay, so the process is complete, and you can see here there are two different enters or entries in the registry. With the name, okay, we have an issue with the date. That's it. That can happen and can be tweaked a little with the prompt. We have the address. We have the sex. So the sex is female. The name is Alexandra San. Okay. The knowledge of validation is yes. Okay. So here you can see the registration dates that are here, and he's taking colorly the year. Okay. So I'm going to, the next step is to send it to the DHIS2. And in order to ensure that this is the right time, and the right address is, and this is not fake, I'm going to put the hour. Okay, I'm going to send to the backend, and here is the payload. So at the end, data is transformed into a payload that will be sent to the DHIS2. Okay, let's go to send to the backend. And it's created a couple of objects. So here you can see the data into the DHIS2 directly. Okay, let's go to the next example. And I cannot see here. So next example, yes, fresh. So let me a more real use case. It's a form from an emergency room register. Also, will be a photo. I'm going to load the photo. In that case, I'm going to select Llama4, that is an open source model. Okay. I'm going to load the file. This is processing. I'm going to show you what the file is. This one. We just delete the names just for privacy reasons, and you can see the different columns. And this is a real example. Okay, it's still processing. I can say you like one thing that we have realized, focus, that the quality of the image is really important in terms of the accuracy of the final data. Okay, it's finished. We have 5 different entries. That's the number of rows here. So we have a female, 20 years old, the temperature. See here, 20 years old, female. The temperature, I think that this is an 8, will be 8 or a 5. So negative of malaria, negative of malaria. The date is -2, it's 9. So this still the manual, the human intervention will be needed at this point. The large language models are good, but maybe not so good. So we need the human intervention. And the diagnosis, let's see here, will be burn left arm and this spinal cord. Okay, and yeah, so we can just maybe fix the issue of the temperature, just to say, or we change the date, and we can send it to the backend, and again, it's sent to DHIS2. We are seeing even programs that it could be aggregated, that will be tracked, that will be whatever. Just a matter of how we tweak the prompt to the generic. So let's go to the next example. Let's move to a malaria case that is reported by email. So, but instead of copy and paste the test, we just take a photo of the email. I'm going to upload the photo. Okay. And this is the email, and we just took a photo of the email with a lot of text that is not relevant for the case of the malaria. And we'll see how the LLM is performing with the extraction of the appeal. So it's kind of John Smith, 40 years old, positive, malaria positive, PV, and the symptoms started 2 days ago. Let's see. So we have John Smith, 40 years old, male, is the 10th of July. Okay, today is 12th, 2 days ago is the 10th. Okay, perfect. And the species is PV. Okay, there may be some mention about fever and headache as the symptoms. Okay, so have fever and headache. And we can send it to the back class as the others. Okay, so let's show something same but different. And now we are going to use, we're going also to report a malaria use case, but using the bots. So the first will be, I'm going to isolate audio and I'm going to upload the audio. For this, I need 2 models, one for transcript, the audio test, and the other is for the generative AI. Okay, in that case, I'm going to use this platform for AI and the LLM. Okay, Lambda. You see that we are playing with different kind of models. Okay, I'm going to upload the audio, and also I'm going to show you what is the audio. What is the audio that I have just uploaded?
Babu Musanga, mwanaume mwenye umri wa miaka 35, anasema kichwa inamuuma na ametapika mara 2 jana na leo. Hizi dalili zilianza jana. Tulimpima malaria na matokeo yalionyesha ako PF positive.
maybe for some of you, it's okay. I don't understand Swahili at all. I speak Swahili, so I don't know what's going on. But looks like the LLM knows it. So he makes a transcript, and from the transcript, he obtains the data. So Babu Nsanga, 35 years old, male, started at this I think it was yesterday, so 1 day ago, positive. Somebody in the room that speaks Swahili? So more or less was he said that more or less? Okay. We are on track, we are on track. Yeah, and as usual, we can send the data to the DHIS2 and we can see it. And maybe the last example that I want to show is a real Rebecca, can you tell me? So what we are going to do is we're going to do one thing first. That is AI. It is not the country. I'm going to add a new data element to the program. And maybe you can just say report a case or a case. You say that the data element. It's not prepared at all. So we can ask programs, what are the management elements, data element. Next visit. So next visit, typically was not in the form, okay, but now will be in the form. Okay, so we're going to report another case. We'll get the audio, and now we're going to record the audio. Selecting this one and this one. Save the pipeline. Are you ready?
Yeah, but where do I have to talk? To this? Okay,
So
I'm gonna
my
share your
computer.
mic.
Okay, so it is like you have here what you can see.
Okay,
Now you see that the next bit is present. Okay.
okay, well, I'm a community health worker. I'm a community health worker. I think I need your mic though. So I was in Vientiane province yesterday. I had a 4-year-old boy come in with his mother. His name was Harry Potter. Mom said his symptoms started yesterday. He had vomiting, fever, chills. So we gave him an RET test. It was positive for falciparum. So we sent him home with a pack of ACTs. He should be done in 3 days. So we will follow up with the mother and schedule the next visit for Friday.
Oh. 2 seconds. More or less is what you have said. So Harry Potter, 4 years old.
4 years old.
Okay, that's good. Male. The data session from was yesterday.
Mhm.
Okay, positive. PF is positive.
Falciparum, PF, yeah, that's it.
Okay. Chills, fever, and vomiting. On the next visit in a couple of days.
Yeah, but I think I said Friday,
Friday.
and that's correct. That's the next Friday.
No.
Oh, I said in 2 days. That's why I said in 3 days. Okay, not bad.
So far, so good.
So far, so good.
Okay, thank you very much. Present to the backend. We have time just to show the. Want to maybe show the. Yeah, we have 3 4 minutes. 4 minutes, okay. I just want to show with you. That's what is happening behind us. We are sending these instructions to the. This is the prompt instruction, and we are sending to the generative AI, to the model. And we are adapting the. We're adapting the prompt depends on the prompt. So we are adapting the prompt means that, okay, taking into account that this data element, the values could be or must be this or that, okay, or maybe things with the dates. So tweaking a little the prompt will improve the final solution. So the results are quite promising, I can say. Testing different kind of models the kind of results. No? So testing open source models and proprietary models doesn't look like there is a winner. Both of them are performing quite good. Audios looks like are easier to digitalize than images. And maybe the cost, we have seen the cost of switching images are higher than audios at this point. And the part of the prompt engineer. Adapting the prompt is key in order to have a better accuracy. No.
Thank you, Telco. I mean, it was Carlos, it was very. So yeah, I think the next step is, yeah, we think that this is quite promising, but as Carlos was mentioning, I think that we should go case by case. And if we are like people normally with feet in the ground, right? So I think that what we really would like to do is to test this in the field with any his, like a kind of a pilot and see how how this is going to work. And for sure, we need to measure the results in both ways, in quantitative and in qualitative. So in quantitative, we need to know how much, what is the quality of the results. Maybe we're going to get even more quality than a human just only digitalizing the forms. Okay, we don't know. We really need to test this. Okay. And also, like, what is the real time that we are like saving for people, for the health workers in order to enter in data manually into, right? So at the same time, we are talking also with the product managers, product lead, and engineer lead in order to see how we can adapt, if it's possible, to adapt this into DHIS2 or not. And yeah, so these conversations are happening. And also that this is rapidly changing. All the environment, all the models. There are more models. Some models are like, some models that were occupying a lot of space in a machine. Now, after a year, we need like probably a machine with way less specs than before. Okay, so we need to be reading, we need to be checking the new models and comparing results. So yeah, we need basically to be aware of the evolution of technology. So I think that's all for all. Don't if you have the time. So in the poster session, so Carlos and Daniel will be there, like for you to test this, so you don't see that there is any kind of trap or something. So we hope it works. So yeah, if you have the time, just try it directly in the poster session. Okay. So thank you very much. Well, I don't know if we have time for questions. Yeah, the representations, yes. Not only for the last presentation.
Yeah, mine is, I think this is really encouraging and promising. There was a very similar work that we had some time in Uganda. It was through a partnership with the technology called Smart Paper Technology. And it was really doing good work at the district to help with the data entry, also for the aggregation. But for them at the time, they're using a very nice scanner. And then they're able to route the data, able to process and then push back into DHIS2. So in terms of if we are looking at this being implemented, that for that kind of a use case where maybe it supports data entry at the district level, how would you typically look at that kind of a deployment with this? Yeah, I think for me that would be the immediate thing to think about.
I don't know if I hear everything because I was to come. But I guess it will be like another implementation, like case by case. We need to think about what are the pros and cons, what are the different, how can we tweak the model. What I have shown is just an approach, and this approach not a web app, but maybe in the future could be like something different. It's just to think about if we can use AI for having data. And using that for aggregate, it should be almost the same that thing in event or in tracker.
More questions. Maybe one more. Already covered time. You can always get anyone of the presenters in the lobby or anywhere. Anyone? More questions?
Thanks. It's almost like mind-bogglingly exciting, to be honest. But I do worry it's gonna put a lot of people out of work, to be honest with me, but, question is, what kind of twofold? First one, are we able to maybe I missed this, are we able to generate new metadata? And if we're able to generate new metadata, most countries are struggling with too much metadata, so are we able to check if that metadata already exists before it's generated?
That's a good question. I see that part of the work that the implementation team is doing is like having some tools based on the LLMs and AI as well that can check the semantics of the metadata, like checking like if the naming convention is the correct one, like trying to find conflicts in the target meanings, if there are duplicates, some of that. So I mean, there are many things that can be done. But yeah, I mean, we are still testing the accuracy of all this. But yeah, that is part of the work that the implementation team is doing as well. Yeah. So there is one more question, the last one. So sorry, guys.
Thank you. So my first question is to know if a country want to adopt this in the national health system, it will be like what we are doing with chat, like a chat call that we can put in a server and then sending the funds to the another server for the same server for the country, or we are going to use your platform or your server that is going to respond. So that's the question for you, but I have for him also. For the AI surveillance or AI alerts, I want to know when you separate the question by levels, to know that that one is minor and that one is major. Is it according to the criteria that you put that the model need to detect in the text, or is it the model itself that learn and say that this is severe or this is minor? Thank you.
Okay, thank you. I hope I have you correct, but during my presentation, as I said, right now we are looking at the rule-based approach, and what we are doing right now is only capturing the keywords that are available or can be captured within the content of the alert. We are not there yet in the model.
And about the first question, this is not a final product. It's just proof, not a proof of concept, I can't say it, but a technical approach. So, but if you want to do that in your own system, you need to select what are the model that you want to use. And if that model can be hosted in your own servers, or could you use it outside your servers. And if you use it outside your servers, you need to know that data will go there and come back in another form. And that you need to take into account the data privacy and other kinds of policies.
Okay. Thank you very much again, everyone. I think it was super interesting session, and yeah, thank you to the presenters.